start today's lecture. Fine. So, Ml Detector. Is it visible and audible?
Yes, sir.
Thank you. Okay. So, Y represents received data. HI hypothesis. So this says that probability of taking decision towards I. Yeah, I just want to make it to be more specific. So let me make it probability of H not Y. Yeah, roll number 5. So what should I keep over here in the top?
Um, Sir, greater than 1 and less than 0.
So if P of H not given Y is
Uh,
greater than P of H1 given Y, then the decision will be taken towards,
Sir, above will be 0 and below will be 1.
this will be 0, right? That means hypothesis H not might have happened, right?
Yes, sir. Yes,
H1
sir.
will be H1.
And
So
H1.
this is dictated by making use of this posterior probability, maximum posterior probability. So this is called the maximum posterior probability, and whichever is going to have the maximum posterior probability, towards that we will take the decision. Hypothesis H naught has been occurred. That's what we are going to take the decision when this is going to be greater when compared with this one. So hypothesis H naught is nothing but sending the symbol S naught. So hypothesis H naught hypothesis H naught means sending the symbol S naught, which is equals to 0. Hypothesis H1 means sending the symbol S1, which is equals to 1. Okay. So as per the Bayes law, this can be written as probability of Y given H naught multiplied with probability of H naught divided by probability of Y. I hope I am writing the correct equation. So this will be H naught, this will be H1, and this will be written as probability of Y. This is nothing but the transition probability. Probability of receiving Y when H1 has been transmitted, H1 has been occurred, multiplied with probability of H1 divided by probability of Y. Actually, probability of Y is called the total probability. Probability of Y is the total probability. Total probability. Total probability, you can able to write it as probability of Y is equals to probability of occurrence of Y when H1 has been occurred multiplied with the probability of H1 plus probability of receiving Y when H0 has been occurred multiplied with the probability of H0. See, at any point of time, if people face difficulty in understanding, please let me know. These are the very fundamentals that you are supposed to have before entering into the much more complex probability equations. Okay. So if I try to compare these two equations, these two will get cancelled, and then you'll be having let me move on to the next slide. So you'll be having a probability of Y given H1 divided by probability of Y. You people parallelly, if you want, you can note it down. Otherwise, it's up to you. We'll be getting the probability of H0 divided by probability of H1, which is equals to, usually we write this as pi naught by pi 1, which is equals to tau map, which is nothing but map constant. This is a constant. Why we are calling it as constant, we'll try to see little later. So if I try to see over here, probability of y given h1, see here what I should write. If you look into the previous slide, probability of y given h1, if this is less smaller, then we are going to take decision towards h1, right? And this is smaller, no, towards h naught. Probability of y given h1, if this is smaller, then we will take decision towards h naught, and if this is small, this is smaller, we will take decision towards h1. Okay, so now I am bringing this to over here. So whenever this term is greater, then I'll take decision towards h1. So what I mean to say is this will be h1 and this will be h1. If you people have any problem, please let me know. Okay, so why this is called a constant? The reason why this is called constant is this is a priori probability. Pi naught is equals to p of h naught and p of h1. These are a priori probabilities which we know before the start of the communications, and a priori probabilities known values, and hence this is constant. So other day maybe Ravina or some person told that we will be comparing it with some threshold, right? The received y will be comparing with some threshold, right? So actually the threshold is this one. Okay, let us try to take an example, and let's have some practical meaning of this. Practical meaning of this map detector. Okay, okay. Now we are going to send the symbols s0 and s1, and we are going to receive the variable y, and this y with reference to a symbol. If s0 has been transmitted, y means at one sample, we will take one sample per symbol. If 0 is transmitted, we will take one sample per symbol, and we will try to compare it with some threshold. What is the threshold? All those things we will try to see. So let us try to take an example now. Okay, this is example 4.1. If I am not wrong, this is from not from SMK. This is from, I think, Hippenshire. One more textbook is there. Anyway, let me give the example. So the source symbols for S0 example 4.1 has been written in my notes. So let it be whether it is 4.1 or not. S0 is equals to minus b. Source symbol S0, I am going to transmit minus b. Source symbol S1 is equals to plus b. Again, I am saying if you face any difficulty, you can at any point of time interfere me. Okay. So, and to be more specific, he says that b is greater than 0, and he has given pi naught is equals to 0.8, and pi 1 is equals to 0.2. Okay, so it should be, the sum should be 1, because that particular set, the source symbol should have S0 and S1. You cannot take S3, and that information you cannot discard. Okay, if required, you can have all the three also. Okay, one such problem I am giving to you as an assignment. Mostly today I will share it with you. Okay, so now this is the information given to you. S0 is equal to minus b, S1 is equal to plus b, and b is greater than 0. Now pi naught is equal to 0.8. Pi naught means this one. This one is 0, 0 point. This one is 0.8, and pi 0, pi 1 is 0.2. And now what he says is, we should know the actually this says that we are supposed to have the detection at the receiver end. This is the receiver and this is the transmitter end. So whatever this information, it is at the transmitter end only. S0, these two are the symbols that I am going to transmit. Pi naught, the probability of occurrence of the symbol S0, he has given us 0.8. So everything is known. At this point, it is known. Next, we would like to know what about the noise. The noise part I am supposed to know. So regarding the noise part, what he says is, he says that the noise is a zero mean Gaussian random variable with variance of sigma square. Zero mean. So the noise follows normal distribution with a zero mean and sigma square variance. This is the information that was given. Zero mean, sigma square variance. That is what given. So now he is asking us to find out. According to map detector, what should be the appropriate decision that I am supposed to take. So were you people clear about the question? The source information is given, source details are given to you, and then the noise part is also given to you. So this is the noise part. It follows the standard normal distribution with mean zero and variance sigma square. Okay, now he is asking us to find out the appropriate decision that the appropriate decision that has to be taken at the receiver end. So once I receive the sample y, y is the sample that we are going to receive, right? So once I receive the sample y, what should be the decision that I'm supposed to take for this particular case of the communication, and how the detection map detector will help us to resolve this problem. Okay, so let us try to go ahead. So is the question clear to you? Is the question clear to you?
Yes, sir.
Okay, fine. Let us go ahead. Now the time is 12:20. The time is running faster. Okay. Now, first what I'll try to do is I'll try to look into this and this source symbols. Okay. So first, let us try to write an equation for this. Okay. So for that, so the noise, it is going to follow the standard normal distribution, which means 0 and variance sigma square. So actually, this is the normal distribution. Normal distribution, fx of x we will try to write. Fx of x we will try to write. Okay. So let me write this as fx of x. So if x is a random variable which follows standard normal distribution with mean mu and sigma square as the variance, then its equation will be 1 upon root 2 pi sigma square exponential of minus x minus mu whole square by 2 sigma square. So this is the probability density function of a random variable which follows standard normal distribution, which means 0 and variance sigma square. The moment when I say standard normal distribution means mu value will goes to 0 and variance value will goes to 1. That is for standard normal distribution. For standard normal distribution, for standard normal distribution, the equation will be modified as, of course, the variable same. I will be considering fx of x, probability density function, 1 upon root 2 pi exponential of minus x square by 2. This is the equation for the standard normal distribution. Standard normal distribution will be having mean 0 and variance 1. So if up to this point, if it is clear, then it will be okay. So the actual graph will be something like this. So here this will be a mu, and the spread somewhere over here will be giving you the sigma square. Okay, or if you want to have only deviation, standard deviation, you can able to have it standard deviation as sigma. Okay, now the thing is, if at all you would like to have the standard normal distribution, this mu goes to 0 and this one goes to 1. That's it. That's nothing more than that. Okay, so the graph, the plot of this equation is this one, and of course the plot of this equation also will be this one with mu value 0 and sigma value 1. Okay, now I am going to transmit, if I try to see the previous slide, I am going to transmit the symbols minus b and plus b. Minus b, I'll be having some voltage. Let us assume that it will be some voltage of minus b volts, and plus b means plus b volts. So if I try to see over here, the n is going to take a random values, right? N is going to take random values that follows this one, 0 mean and sigma square variance. So for 0 mean and sigma square variance, the only difference that you are going to have is, since here it is 0 mean, so x minus mu whole square, this term will remain the same. Sigma square means here one more term will get added, that is sigma square. This term will get added over here. So if I try to look into the problem which I am going to solve, so let me take this blue color. So for the R problem, here you are going to have sigma square. That means this one will be coming over here, because in the problem it was given as the mean 0 and the variance is sigma square. Now when we are going to transmit the symbol minus b, let us start with the symbol minus b. When I am going to transmit the symbol minus b, what will happen? See, n is just a random number. So n is going to have a set of random values. So some 0.13578 line, and so on, set of random values you are going to have. Now when I'm going to transmit a minus b symbol, each and every random variable is getting added with minus b. Are you following what I'm saying or not? What I'm going to say is, in our last class discussion, when we try to transmit the symbol 1, we found that the mean value has been shifted to the 1. Okay, because each and every sample of the random variable noise is getting added with the voltage value 1. So in the similar manner, if I try to follow the same consequence, same similarity, if whenever I try to transmit minus b, what will happen is the random variable capital X or the noise variable will be having the mean value minus b. That's what I want to say, and the variance will not get affected. Variance will not get affected. So for our problem, the probability density function f x of x is equals to, or probability density function of the noise, 1 upon root 2 pi sigma square exponential of minus x square by 2 sigma square. Actually, one more modification is required over here. Here, one more term will get added over. This term will get added over here. Okay. Now, when I try to transmit the symbol minus b, so minus b, if I try to transmit, then the mean value. See earlier, this is the curve. Now, because we are transmitting the symbol minus b, so the mean will be shifted to minus b. I hope people are following. So that means probability of receiving y when h naught has been transmitted is equals to 1 upon root 2 pi sigma square exponential of minus, actually x minus mu whole square we will write. X minus mu whole square means it will be x plus b whole square by 2 sigma square. This is the transition probability that we are going to have when the symbol h naught has been transmitted. Is this point clear to you? And if at all you would like me to draw the graph for this, let me use another color. So the color graph will be so this is minus b. Okay. In the similar manner, if I try to go for the calculating the transition probability of receiving y when h1 has been occurred is equals to 1 upon root 2 pi sigma square exponential of minus x minus mu whole square b whole square by 2 sigma square. So this is for the hypothesis h1, and for that, if I try to use another, let me use the blue color. So somewhere here, that is the some plus b, and somewhere over here 0. So this is what the transition probabilities. So this indicates probability of receiving y when h naught has been occurred, and this indicates probability of receiving y when h1 has been occurred. Okay. Is this fine? Clear? Yeah, it should be clear. Okay. Now, so as per the map detector, as per our map detector, map ఏం చెప్తుంది? What map says? Probability of h naught given y, if it is greater than probability of given h1 given y, then I'll take decision towards h naught less than h1, so equals to whichever the way that you. This is what the map says. So again, I don't want to do the same mathematical equation repetition. Instead, I'll try to go straight away to this particular equation. So probability of y given h1 divided by probability of y given h naught less than greater than pi naught by pi 1. If I am not wrong, I believe this is h naught and this is h1. All right. This is the final equation what we had obtained from the map detector. So if I try to substitute the equations what we have obtained for the given case, this equation and this equation, if I try to substitute in this equation, and of course pi naught value is given to you and pi 1 value is given to you. If I try to substitute this, then you will be having the left side part an equation which is completely in terms of y. So because here this is completely in terms of y. Of course, b is a fixed value. Sigma square, b sigma square are constants. B sigma square are constants, and you will be getting an equation in terms of y. Y is the only variable that we are going to have. What do you mean by y? What do you mean? Okay, fine. You people might be having a confusion over here, right? So here the variable is x, here the variable is y. So that's a mistake what I have done. So what I supposed to do? If I try to write y over here, this also should be y. If I try to write, see, it is just a probability of occurrence of the variable y when h1 has been occurred. That's the only thing that you are supposed to have. If any, this is for the probability density function of the noise. Okay, because we are considering the received variable as y, we are supposed to have these equations in terms of y only. So what I mean to say is, this is actually the y that you are going to have. Here the x-axis is y. Here this x-axis is y. So what does it mean? For suppose if I try to consider this probability density function, I'll try to explain what this means. To be frank, it won't go to zero indefinitely over here. Instead, it will going to this zero somewhere after this. Okay. So if I try to calculate the area under this curve, if I try to calculate how to undo the undo option is also there. Anyway, so if I try to calculate the area under this curve, what it will say is it will gives you the value of receiving y whose value is less than minus b. The probability of receiving y okay. So if I try to calculate this area, you will be getting the probability of having y when h naught has been transmitted whose value is less than minus b. And so for suppose b is equal to some 10 if I take, b is equals to 10 if I take, so minus 10. So y can take any values from minus infinity to plus infinity. Y can take any values from minus infinity to plus infinity. So what is the probability that y will take the values less than minus 10 when when minus 10 has been transmitted? Since we have taken b is equals to 10, what is the problem? See, b is equals to 10 means we are transmitting minus 10 at the transmit end. So what is the probability that the receiver will be having the values less than minus 10? Less than minus 10 means minus 11, minus 12, minus 13, minus 14. All those things, if you would like to calculate, just calculate the area under this. That's it. What is the probability?
Sir,
Yeah, please, question.
sir, probability always in between the 0 and 1.
Obviously, certainly.
And
The area of this curve will also be equals to 1. The area of yeah, this area will be always equals to 1. This equation area will be always equals to 1. This equation area also will be equals to 1. If you want, you can calculate it. That's because it is representing the probability density function. What is your question then?
no,
Yeah, what is your question?
here b equal to mean, sir. You are telling that in that first curve b equal to mean.
Yeah.
So
This is minus b is the mean value, average value.
so left part of b and minus b and the right part of minus b both are equal. That is
Yeah.
0.5.
Yeah, obviously.
And you are telling that it will be minus b value, minus 10, minus 20.
Okay. Actually, I understood what his name. I believe it is Shivana.
Shiva.
Shivana. Okay, I
Yes,
think.
sir, Shiva.
So he don't want me to write here B. Okay, obviously, I'll be making it as a. Actually, my intention is not this one. Instead, my intention is what is the possibility of y taking the values less than minus b? It's not this one. Yeah, what he has identified is right. Probability will never be goes beyond 1. So my intention is what value, what is the probability of y taking the values less than minus b. So that means y can take any values from minus infinity plus infinity. So if it is the case, what is the probability that y will take the values less than minus 10? So my y will take the value minus 10, minus 20, minus 30, minus 40, minus 50, minus 100, all the values it will take. So I would like to find out the probability that y will take the values less than 10, less than minus 10. So that means as per his words, because it is exactly at the center, minus 10, we'll be getting the probability will be zero point 0.5. So that means this probability, to be more specific, probability of y having the values less than or equals to minus 10 when h naught has been occurred is equals to 0.5. Now, okay, Shiva?
Okay, sir.
Right. Okay, now, where we were, let me see the next slide. Okay, now I would like to substitute these two equations over here. This equation, and this equation. This equation and this equation. I would like to substitute in this equation. So let me try to write over here. So here 1 upon root 2 pi sigma square will be same for both the cases. If you follow the previous equation, I would like to place this in the numerator and this in the denominator. So these two will get cancelled. I hope this term and this term will get cancelled. I hope you people are following. Only these two will be remaining. So I will try to write only these two. Okay. So let me take the eraser. Okay. So here exponential of minus x minus b whole square by 2 sigma square. Yeah, again it should be y, right?
Yes, sir.
Yeah. I'll let me overwrite it. Anyway, you people know this.
Sir,
So you should know, huh?
Sir, above symbols representation should be reversed, no, sir.
Huh?
Uh, above equation, sir. First,
This equation
in the place of h naught, h1 should be there, sir.
in place of h naught.
Reception representation, sir. In the middle, above arrows.
Pi 1 by pi naught, sir. Pi 1 by pi naught.
Not that, sir. Yes, sir. From this equation.
Any doubt now?
Yes, sir. This is right. The next one you wrote is reverse, sir. In the last slide, and
Wait. So probability of y1 divided by probability of y given h naught. Probability of y given h naught. So obviously, if I try to bring this term over here, so when p of y divided by h1 divided by p of y given h naught, if this whole term is greater, then I should take decision towards h1, right? If the left side term is greater, I think this is wrong. If the left side term is greater, then I should keep here h1. Am I right or wrong? You want me to write again here? So I'll rewrite over here. You see here. So now this inequality is right? So
yes.
if this okay, now I'll write over here. So probability of y given h1 divided by probability of y given h naught. So this term I have taken this side. Okay. Now if I try to consider this greater sign, if this is greater, okay. So if this is greater, then I should take decision towards h1. If this is smaller, then I should take h0. So this will be pi naught by pi 1. So what it means? So when the left side term is more, I'll take the decision towards h1. I don't know what is your name. What is your name?
H1.
So do you agree with this point?
Yes, sir.
So if this is right, then we have done a mistake over here. So if this term is greater, that means here I should have 1. Am I right or wrong?
Yes, sir.
Am I right or wrong?
Yes, sir.
మాట్లాడండి, మిగతా వాళ్ళు మాట్లాడండి. See, only two people are talking. See, in this particular equation, see, up to this particular point is right. So here, what I have done, so here I replace with probability of y given h1 multiplied by ph1. So these two cancel. ph1 divided by py, probability of y given h0. If I try to use, if this term is greater, I should consider h1. So that means if this term is greater, I should consider h1. The equation, this is wrong actually. Earlier I have written here h1 and h0. So if this is smaller, then I should take direction towards h0. Lokesh, Beulah, and Ravina, and other people, were you following what I am saying?
Yes, sir. Yes.
Why you people haven't
Yes,
tried it?
sir.
Where is the concern when I have written wrong over here? Because when this term is greater, I should take the direction towards h1. That's what we'll get over here. When I try to bring this term this side, we'll be getting p of y by h1 divided by p of y by h0. So if this term is greater, I should take the direction towards h1. And if this term is smaller, I should take the direction towards h0. Okay. Then because I have something in my mind, that's the reason why. So when this term is greater, I should take the direction towards h1. This is right actually. Yashwant,
Yes, sir.
now your doubt is clarified?
Yes, sir. Right.
Okay, fine. So exponential of minus y plus b whole square by 2 sigma square. I hope you people are following. Less than, greater than, h naught, h1, pi naught by pi 1. So now if I try to make this above, exponential of minus 1 by 2 sigma square. So y square plus b square minus 2yb plus y square plus b square plus 2yb less than, greater than, h naught, h1, pi naught by pi 1. So exponential of minus 1 by 2 sigma square. So because this is the first time I am doing all the derivation, otherwise I am very lazy person, you see. Minus 2yv plus 2yv will be gets cancelled. So of course here 2y square were there, 2b square were there, 2 also will get cancelled. So y square plus b square will be there less than pi naught by pi 1. So h naught, h1. So if I try to apply natural logarithm here, so minus 1 by sigma square y square plus b square less than natural logarithm of tau map, I'll write. Okay. So the sigma that side I'll try. Any queries?
Sir,
Yeah, please.
sir, it is exponential term by exponential. So the later part should be subtracted minus y square minus b square minus 2yb. So denominator part will get subtracted from numerator part, right?
Thank you. Thank you. Thank you. So let me take another color to do the modification. See, e power this, when this term comes up, it should be plus, right? That's what she is saying, if I'm not wrong. Yes. Yes.
Yes, sir.
Yes.
Yes, sir.
Fine. Fine. Then if it is the case, I believe here it will be minus, 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 right? Right.
Yes, sir.
Because I
Yes,
have
sir.
taken minus common here, minus 1 by 2 sigma square common here. So y minus b whole square, minus y plus b whole square. Right? Right? చెప్పండి, yes or no?
Yes, sir. Plus
Yes, sir.
4yb. Plus
So
4yb.
these two will be cancelled, these two will be cancelled, plus 4yb. Okay, let me take care of that then. So you'll be getting my minus 2yb will be left out, minus 2yb plus 4yb. So plus 4yb. Let me take again red. So minus 1 by 2 sigma square. So minus 2yb, minus 2yb, minus 4yb. So plus 4yb, right? So two twos. Okay. So if I try to apply natural logarithm, I will be having 2yb by sigma square, right? 2yb by sigma square, natural logarithm of tau map. Okay. So sigma square, if I try to cancel, and y should be sigma square by 2b natural logarithm of tau map. Okay. So if sigma square y less than means h naught, and what this means is y, the sample which you are taking over here at the, if this is the channel, here you'll be getting y, right? So we are going to have one sample per symbol, one sample per symbol. When I transmit the symbol s naught, I'll take one sample. That sample value I'll try to compare with this threshold. And if that sample value is if y is less than this threshold, then I'll consider that it is h naught. That means source symbol s naught has been transmitted. Otherwise, it is h1. Source symbol s1 has been transmitted. If you perform a MATLAB simulation relevant to this, you will be getting very nice understanding of this particular thing. Okay. So what's the time now? What is the time now? Yeah, 12:45. Yeah, I think it's a little bit more time is there. 15 minutes time is there. So is the point clear to you all?
Yes,
Is the
sir.
point clear? So actually, why is the most important thing that you are going to have? Why is the sample that we are going to have at the receiver end? So from the transmitter to the receiver end, I transmitted source symbol. See, let me consider this is source symbol. This is source symbol. So the source symbol, let it be some one. So one has been transmitted. Okay, it has been received here. Some noise has been added. So what I'll try to take, I'll try to take one sample. Just I'll cut it down and I'll take just a simple sample, and I'll try to check it with this number. I'll try to check with this number. So if the sample y is less than this number, then I'll take that the decision is h naught. Otherwise, the decision is h naught. Okay, that's what you are supposed to do. Okay. So if you want, you would like to substitute the values. Tau map is equals to 0.8. Pi naught is 0.2. 0.2 divided by 0.8. So 0.2 divided by 0.8 means 1 by 4. 1 by 4 means 0.25. Natural logarithm of 0.25. And if you have any values of this, you can check it out. And that will be used for the, because sigma square is constant that you have obtained from the noise characteristics. B is also constant that also you have obtained from source information. So you are going to transmit the symbols plus b and minus b. So this is the way how you are going to do the thing. Now, what I would like to say is, most important thing, this is called a likelihood ratio. That this is called a likelihood ratio. Let me use another color. Likelihood ratio. I don't know whether you remember or not. The transition probability sometimes also considered as a likelihood function. This is likelihood function. Likelihood function. This one is likelihood. This is also likelihood function. Okay. So this is called the likelihood ratio, and usually we'll represent it with L of y. So L of y less than or equals to greater than tau map. This is what actually the condition for map detector. This is the condition for map detector. Okay, now. Okay, మీకు ఒక స్పెషల్ కేస్ చెప్తాను చూడండి. I hope you'll be understanding what I am saying. So sigma square 0.2 by pi naught is 0.8, right? ఏం మాట్లాడేంటండి?
Sir, it should be 0.8 by 0.2.
That's what I am expecting. 0.8 divided by 0.2, you'll be getting 0.4. This is. Let me write inverse. Okay. Sigma square by 2b. Let me do it over here. So y sigma square by 2b. Sigma square by 2b natural logarithm of 4. Natural logarithm of 4. Okay, a special case తీసుకున్నా. Let's try to take one special case. Which color you like? If I want to tell you, yeah, green. Let me take green.
Green, sir. Green.
Yeah, I had taken the green only. Special case. What the special case says is pi naught is equals to pi 1 is equals to 0.5. Okay. So if pi naught is equal to pi 1 is equals to 0.5, and the noise 1. Okay. So likelihood ratio H naught H1 tau map. Actually, this tau map now it will be 1, right? 0.5 divided by 0.5. So if I try to calculate this, 1 by root 2 pi sigma square in the numerator and denominator both will be the same. Okay, up to that point it will be okay. So exponential of numerator will be and the source symbols, let us assume that the source symbols are 0 and 1. The source symbols are 0 and 1. 0 and 1 means s naught is equals to 0, s1 is equals to 1. Okay, so minus x minus mu whole square by 2 sigma square. So x, yeah, why always x will come to me? Why, right? Okay, y minus mu whole square by 2 sigma square. Okay, so exponential of minus, so minus will become plus 1 by 2 and y square. Am I right or wrong? Am I right or wrong?
Yes, sir.
Okay, so if I try to solve this, we'll be getting, what will be the condition for y? H naught H1. If I try to solve this, కళ్ళు మూసుకొని చెప్పేయచ్చండి.
Zero, sir.
0 ఎట్లాగండి? Okay, probability density function, if I try to plot for S naught, the probability density function will be something like this. The mean value is 0. And for S1, the probability density function will be something like this. Here the mean value is 1. Now what will be the value over here? Can you guess? చెప్తారండి,
0.5, sir.
మీరు అంతా సాల్వ్ చేసి చెప్పండి. ఇక్కడ వచ్చే వాల్యూ మాత్రం 0.5. It's very simple. You see, so the first PDF is going to have 0, the second PDF is going to have 1. So now, actually, the exactly center point, this is what the threshold is, and that is fair also. That is fair also. If you try to consider this curve, maximum opportunity probability says that if P of this is nothing but P of y given H naught. This is P of y given H1. దీని likelihood function కూడా అంటారు. This is also considered as likelihood function. Okay, so if you want, you check it. ఎవరైనా చెక్ చేశారండి?
Yes,
Have you,
sir.
is it right?
Yes, sir. Yes, sir. 0.5.
0.5, right? So now, if you try to see this one, if you try to observe this, this is called likelihood function. This is also called a likelihood function. So
Sir,
if I write, yeah, please.
sir, how it is 0.5, sir? It is actually 0, sir. ln of 1 is 0, right?
Yeah, let me do it. So ln of 1 will be 0, right? So
Yes, sir. 0.
minus 1 by 2 plus y square by 2, 0, right? So 2 goes to minus y minus 1 whole square plus y square, 0. Okay, so minus of y square minus 1 plus 2y plus y square. Okay, so minus y square plus 2y square cancels. So if I try to bring this minus 1 this side, you will be getting 2y 1 and y. Now okay. Now okay.
E is there, sir. E power.
Yes, sir.
అర్థమైందండి.
Yes, sir.
Okay. So this is called likelihood function. Now here I can write one thing from this particular equation. Yeah, let me take. So probability of y given h1 divided by probability of y given h0, right? So this is h0, this is h1. దీని ఇంకో మాటలో రాస్తే probability of y given h1, probability of y given h0, likelihood function. So whichever the likelihood function is going to have more value, towards that we will try to take the decision. So if this likelihood function is more compared to this one, then I'll take the decision towards this, that is h1. If this likelihood function is more, actually, then we will try to take the decision towards this symbol. Okay, so if you try to see, this is the likelihood function. So up to this particular point, if you try to see, this likelihood function value is greater than this likelihood function value. So that is the reason why below this you will try to take the decision towards h0, and after this this likelihood function value is very less as compared to this likelihood function value. So that is the reason why we will try to take the decision towards this one, and hence this is called maximum likelihood function, maximum likely ML detector. So two types of detectors we have completed. First is map detector and second one is ML detector. ML detector is a special case of map detector. Maximum likelihood detection means we will be having the probabilities 1. ఏమన్నా అర్థమైందండి?
Yes, sir.
So I will be giving one problem for today. You try to solve that, including MATLAB simulation. Next class we'll be doing something else. If you have any queries, you can ask. So you can say that actually different types of errors also will be there. Now the time is 12:57, so I think I have to leave now. Anyway, any questions if you have, you please ask me. Questions please, Lokesh, Sujan, Ravina, and some names I forgot. Shiva. Questions please, queries please.
Sir, why you are always considering the Gaussian distribution? Many distribution functions are there. Rayleigh distribution function, Poisson distribution function, binomial distribution functions are there. And why you are considering only Gaussian distribution?
Shiva, do you know central limit theorem?
Yes, sir. No,
What
I
is it?
am. I was studied, sir, but I forgot.
Okay, you can take any. There is no such reason behind choosing only the Gaussian. But actually, central limit theorem, the one statement what it says is, if you have n number of different variables, let me consider Gaussian, uniform, Rayleigh, whatever be the random variables it is. If you try to add all those different types of random variables, ultimately you will be reaching to this Gaussian distribution.
Gosh.
Okay, Shiva. There is no
Okay, sir. Okay,
restriction
sir.
to choose only Gaussian distribution here. If you try to see a textbook, if you want, I can give another problem as an assignment which uses binomial distribution. Okay.
Okay.
Any other question? Okay, you can contact me maybe later also, no issue. Thank you all. You can leave now.
Thank you, sir.
Thank you, sir.